Good morning. Bienvenidos a TechEd. That's about as much Spanish as I speak, unfortunately, but maybe by next year, when we come back, I'll have learned a bit more. My name is Paul Robichaud, and the session I'm going to be presenting today is talking about developing mobile applications that use Exchange Web Services. So, before we get started, how many of you have already developed or are developing an iOS application? Anybody? Android application? Windows Phone application? BlackBerry application? Okay, good. I didn't want to have to throw the BlackBerry people out of the room, but that's where this was headed. How many of you are primarily Exchange Web Services developers? Okay. How many of you came in here because you heard there were good snacks? Okay, I'm sorry to disappoint you if that's the case. By the way, one thing I learned yesterday, if you wait until the end of the lunch period, all the ice cream will be gone. I learned that after working Ask the Experts yesterday. It was very disappointing. So, to set the stage, let's talk about mobile devices for a minute. Is there anybody in here who does not have a smart mobile device? Anybody who has a flip phone or feature phone or candy bar phone? That's about what I expected. Number one, we're at a conference full of technical people. But number two, throughout Europe, throughout North America, throughout much of the Pacific Rim, the market for limited feature phone devices is shrinking really quickly because people see and want all the stuff that they can do with more robust mobile devices. They want applications based on location services. They want cloud-integrated applications such as the ones that Microsoft was talking about yesterday in the keynote. They want to be able to leverage the power of having a small, powerful computer that can talk to a large network of much larger, more powerful computers. But there's a problem with that. Okay, one problem is that we're still trying to figure out some of the social interactions around everybody having an internet device in their face all the time. For example, when I have dinner with my kids, the rule is nobody's phone may be visible. So what that leads to is my kids doing this when they think I'm not looking. I got the phone in the wrong pocket, but they'll pull it out and hold it under the table and look down like they're looking at their napkin as though they think I won't notice that. More importantly, though, there are a lot of technical and business considerations that come along from having these ubiquitous mobile devices. One, how many of you have heard of Bring Your Own Device, or BYOD? Okay. One of the big drawbacks to BYOD is that when you let people bring their own devices, they think, hey, that's my device. I should be able to do with it what I want to. So they install software on it and they configure it, often in ways that lead to poor security. So the alternative is to have company-provided devices. Now, this is a mixed bag. There are some companies who are happy to provide devices to their employees, but more often, from a security standpoint, when you start telling companies, yeah, you've got to provide devices to your employees in order to keep your network secure, you know what happens? They don't provide any devices to anybody, and then everybody's unhappy. So one of the ways that enterprises are starting to work around these issues is to say, well, if we build our own applications for our own line of business needs, then we have the ability to make them as secure as we want. We can have the kind of authentication we want. We can talk to the back-end data sources we want. We can put use controls or auditing or whatever we need in place. And it turns out that one very common source of data that people want to use in these applications comes from Exchange. Now, really, just from a platform perspective, right now there are 3 platforms that are clearly leading in the market. There's Google Android, which has many, many, many different variations. There's Windows Phone, and there's Apple's iOS line. Now, one of the problems with mobile development is that the APIs and platforms for these 3 devices are completely different. Okay, if you want to write code that runs on Android, you're going to be writing it primarily in Java, which means that you can't run it on Windows Phone and you can't run it on iOS because those machines don't have JVMs. There are third-party libraries and compatibility tools that help make this problem simpler, but for the most part, what most companies do when they're thinking about developing a line of business application is they pick one platform. That becomes their primary platform, and then they may port their application to another one, but they don't follow the same strategy that commercial application developers usually do of trying to simultaneously ship across multiple platforms. So, just to set the stage, I don't intend this to be a session that focuses on the strengths or weaknesses of any of those particular platforms. I'm going to talk about iOS for one reason. I know about iOS development. I don't know anything about Android development. When I have time, I would love to learn more about Windows Phone development because I carry a Windows Phone every day. But I know enough about iOS to be able to talk about that as a means of using these Exchange APIs. Okay? So really, when we talk about Exchange, there are two separate things that we're talking about. One is Exchange Active Sync. You can think of this as a mechanism for synchronizing Exchange data between any device and Exchange. It has some policy controls built into it, but it's primarily a connector, for want of a better word. It's really, really, really ubiquitous. Microsoft's competitors use it. Google uses it. IBM Lotus. Do I have any Lotus Notes administrators in here? Okay, I won't hold that against you. Device manufacturers of every kind. It caused a lot of internal tension within Microsoft when the Exchange Active Sync folks started licensing Exchange Active Sync to companies such as Apple, because the Windows Mobile team didn't like that at all. But the fact of the matter is that Exchange did the right thing, because now we have this great, robust, well-understood, mature sync system that we can leverage in our applications if what we want our applications to do is sync stuff with Exchange. More often, though, what we really want is we want to get into Exchange and get some live data. We want to see which people are available at a given time. We want to know, based on a map, where is the nearest service truck and when is it scheduled to be free. Okay, we want to know what somebody's out-of-office state is, so that if we have 10 people who could do a job, on our mobile app, we want something that will show us right now, here are the 10 people who are qualified or certified to do this task. 3 of them are out of office, 1 of them is on vacation, 2 of them are on a call. Here are the ones that are left. Tap their name, and you get a call out to them. So what the application does is driven by whatever the business does, which in turn is driven by what's available in the Exchange store. The cool thing about Exchange is that that's where all the data lives. Right? You've probably heard a lot about the U.S. National Security Agency. Anybody ever hear of them before? Yeah, nobody's raising their hands because they're afraid we're being recorded. A lot of the discussion you hear around NSA centers on metadata analysis. Okay? And that's not precisely the right term, because from a cryptographic or a security standpoint, what they're really doing is traffic analysis. What we can do here, though, with all this data we've got, is we really can do metadata analysis, because we've got all this data about who's talking to whom and which resources, which people, which objects, if we have things like projectors or turbines or other kinds of repair equipment. If those things are reservable in Exchange, we can do a lot of analytical work to tell us which ones to use. Do any of you, or have any of you worked in call center applications? That's a big thing with Link right now, because one of the things that a call center should do is figure out, if you've got 100 operators who are answering the phones, when the phone rings, how do you know which operator should get the call? Well, there are a lot of different ways to do it. The most common one is find the person who has had the longest time since their last call and give it to them. Okay? Well, with Exchange, you have data in the calendar that lets you figure out things like, okay, who is the person who is least busy based on what's in their calendar? Who is the person who is geographically closest to whatever it is I'm trying to do based on their work location? and who is within working hours right now as based on their Exchange calendar, and has a status that is not set to out of office or working outside the office. Okay, so people already put all this data in because we all put our own calendar appointments in. We all put our own out of office status in. So what we want to do now is talk about how we can build applications that take advantage of that to do something useful. So as I mentioned, my primary interest is going to be in talking about using Exchange Web Services and a little Exchange ActiveSync to build applications for iOS. I am not an expert iOS developer, so from an iOS perspective, this will probably be about a 200-level session. And then I want to show you some examples and share some things with you that I've learned about how to develop these applications, good and bad, some tips that may help save you some time if you decide to do something similar. Okay, what I'm not trying to do, I'm not trying to teach you about Android development because I don't know it. Windows Phone has already got an excellent set of APIs that are much simpler to use than the APIs we're going to be using today for iOS. Now, there are many differences in the paradigm that you have to follow to develop a Windows Phone app versus an iOS app. But one of the big differences that pertains to us is that Microsoft has given us a really good managed code API to do all this Exchange Web Services stuff. Whereas for iOS, we have to hand roll our own. So the managed EWS API is great if you're writing an application that runs on Windows 7, Windows 8, Windows RT, Windows Phone. Now, if you've been paying attention, you know that pretty soon we're going to be down to Windows 8 and Windows RT and Windows Phone. And I would bet that by the time TechEd 2015 rolls around, we're going to be hearing about just Windows. There'll be one Windows, it'll run on small and large devices, and that will end all this confusion about who does what, where, and which APIs to use. But in the meantime, the managed API gives us a very simple interface to do things such as, hey, find me all the calendar items between today and next Wednesday. That's literally one line of code. Okay? The problem is that on iOS we can't use it because this is written in managed code intended to be run from a platform that uses the .NET framework. So instead we have to do some stuff on our own. And there's a basic pattern that we can follow to get these things done. The first step in the pattern is that we'll create a blob of XML that has the data in it we want. Okay, if I say SOAP as a programming idiom, does that make sense to any of you? Any of you heard that term before? Okay, a few. SOAP stands for Simple Object Access Protocol. It's basically a scheme for a client and a server to cooperate so that the server will receive a block of XML that has some elements in it that the client wants to share. And then the server will parse that element and do something and then return a block of XML as response. So what you're going to see when we start looking at these blocks of XML is that they are wordy descriptions of operations that we want to happen in a particular format that the server expects to see. So there are a bunch of different ways that you could construct these blobs. The way that I chose to do it for building these demo applications is I took Windows Phone 8 because I knew it worked, and I pointed it at Fiddler, which is an SSL proxy. And then I pointed Fiddler at my Exchange server. And I did something on the phone, and that generated a log of the traffic that was going back and forth so I could look at it and copy the XML and figure out what it was doing. There is a very good book called Developing for Exchange 2000 Web Services, but the problem is it reflects the Exchange 2000 version of EWS. So that's not to say that it's not useful. It just doesn't have a lot of the stuff in it that we got in EWS in Exchange 2010 and in Exchange 2013. For example, it doesn't discuss building inbox rules using EWS because those features didn't exist. It doesn't talk about how to get high-resolution contact photos because there was no such thing at the time. So the gold standard for figuring out how to talk to the server is have another device talk to the server and see how it's doing it. So once you've got a block of data that specifies what you want the server to do, and this may be a request for some other information, it may be a command telling the server to do something, it may be a response to something that the server has asked you to do. You'll send it back using an HTTP post operation. And HTTP here is a little bit of a misnomer because really it'll be done using HTTPS. But in either case, you're going to see this same operation over and over and over. You're not going to see HTTP GETs being used. So you'll build a block of XML, you'll post it to the server, and then the server will send back some kind of response. Now, the response that you get back could be an actual HTTP error from the server. For example, it's not uncommon to get back a 500, which is internal server error. Generally, that tells you that your XML was so screwed up that Exchange couldn't figure out what it was supposed to be, so it quit trying and it sent back error 500. More often, though, let's say that you built a structure to do something like set someone's out-of-office state, and you forgot to tell Exchange which mailbox you wanted to change state on. Everything else was correct. You just left out that one data item. Then Exchange will send you back a block of XML that actually contains an error. And so when you think about this structure, remember that you can have more than one of any of these things. So when I'm building the block of XML in the first place, suppose that I was writing some code that would upload a set of contacts to a contacts folder. The upload request might have 200 contacts in it. That would be perfectly legal to do. So the response that I get back is probably going to have 200 response items, one indicating the success or failure for each one of the contacts that I added. So I can't just look at the HTTP result code that comes back to tell whether my operation was successful or a failure. If I sent up 200 contacts, I have to check all 200 responses, because it may be that the first 150 of the contacts went through, and then number 151 had some kind of problem that I need to resolve by re-uploading the contact or by giving an error dialog to the user or doing something. So how do we do this in practice? Well, before we can do our magic of building a blob and posting it, we have to know where to send it. And to do that, we use Autodiscover. Now, technically, Autodiscover is not one of the Exchange web services. It's actually part of Exchange ActiveSync spec. But the whole reason we're using it is because we want to be able to ask the user for something simple: their email address and their password. We don't want to have to ask them what their Exchange server URL is, because they may not know. We also don't want to ask them, because if we ask them today, it can move at any time. How many of you have customers who are on Office 365? Okay, a couple. One of the beautiful things about 365 is that you never know where the user's mailbox is, and you don't know what server they access it from. They go to mail.office.365 and they log in. They get redirected to a URL that points to their actual Outlook web app server. Off you go. If Microsoft moves that mailbox tonight while they're asleep, tomorrow when they log in, everything gets redirected. They turn on their mobile device to sync. It performs an auto-discover. It gets redirected. So this is exactly what we want. Then we're going to use Exchange Web Services themselves to do whatever it is our application does. So with those APIs, we can read any data item in the Exchange store to which we have access. So contacts, calendar items, mail messages, folders, inbox rules, call answering rules, contact photos. Basically everything in the Exchange store is available to us. Now, there's a good news part of that and a bad news part. The good news is, because it's accessible, we can work with those objects as much as we need to in any way that we want to. So if we wanted to write a tool, for example, that would walk through the entire user population on an Exchange server, and set up a call answering rule that would forward calls to a particular location, we could easily do that. On the other hand, anytime you do bulk data manipulation like that, you run the risk that you'll break something, for one thing. And you have to keep in mind that there are constraints from a support standpoint of what items you can touch and not touch. Right? So for example, there are unified messaging greeting objects that are stored in the user's mailbox. You can get to them through EWS, but Microsoft doesn't support modifying them. So if you modify them, you're kind of at your own risk. So let's talk about AutoDiscover for a second. Exchange ActiveSync itself is really three things. It's a spec that Microsoft publishes. It's an implementation on the Exchange server that implements that spec, and then it's a whole gaggle or herd of clients that implement that spec, some of which do it better than others. Most of the time when people ask questions about EAS, what they're really asking is, okay, I want to write my own calendar client. I want to write my own client that will let me synchronize items on a device with a SharePoint list to an Exchange folder. I want to use EWS to actually migrate email. There are products out there that do that. So when you run them, they use EWS to pull all the contents out of a mailbox, and they use EWS to put those contents into a new mailbox. So there are a lot of different things that you can do with it. But from our perspective, EAS is primarily interesting because it's the host for AutoDiscover, which everybody needs. So we want to use AutoDiscover to get the minimum amount of information from the user and then turn that into everything else that we need. It works differently for clients that are joined to an Active Directory domain and those that are not. We can ignore the whole notion of domain-joined AutoDiscover for right now. I think in the future this is going to change. If you look at what's in Windows Blue and the notion now that you can have a device that is not domain-joined but is work-joined, right? This is probably going to have to undergo some change. But at least for right now, we don't have to worry about doing AD lookups to look for service connection points or using Kerberos for authentication. That all just drops out. So instead, our basic workflow is that we'll collect some credentials from the user. Then there's a set of well-known URLs that you go to looking for AutoDiscover services. So when you connect to one of those endpoints, if you are successfully able to hit that URL and authenticate to it, then you'll get back what we call an AutoDiscover manifest that has a bunch of information in it that you can use to connect to different sorts of services. When we request that URL, we're going to get back one of essentially three things. We will either get back a complete manifest, we'll get back an error of some kind, which generally means that our AutoDiscover request is wrong in some way, or we may get back a redirect that points us someplace else. So if we connect to a CAS in Madrid and our user's mailbox is actually in London, then the Madrid CAS may redirect us to ask again by pointing us to the London CAS. So a client that is doing AutoDiscover has to be able to handle all three of these cases: getting a legitimate response, getting an error, which may include an authentication request, or getting a redirection that points someplace else. And in fact, in Exchange 2013, the CAS no longer generates HTTP 451 redirects for AutoDiscover. We used to do that, and it turns out that a certain very large smartphone manufacturer based in Cupertino, California, their devices couldn't handle 451s. So rather than continue to have people complaining, well, my phone doesn't work with Exchange, it must be Microsoft's fault, Microsoft just decided to turn off that type of redirect just because one particularly large popular device family didn't handle it properly. So I mentioned well-known URLs. So what we'll try to do during the AutoDiscover process is start by doing an HTTPS post to whatever the SMTP domain of the user is, followed by AutoDiscover, whack AutoDiscover domain.xml. If that doesn't work, then we'll try autodiscover domain.com, whack autodiscover.xml. It's possible that both of those will fail. If they do, then we'll try doing an HTTP GET to that URL in the hope that that will then trigger an HTTP redirect to where the autodiscover endpoint really is. This is a common situation when you have a web server for a company like www.contoso.com, and that's the only public-facing website that you have, right? So you don't have and do not want to expose a CAS directly to the internet for this. So what you do is you create a CNAME for autodiscover and point it at the www.contoso.com machine, and then set it up with a redirect using Apache or using IIS or whatever web server you're using. So when a client gets to this point, it does the HTTP GET, and it gets redirected back to mail.contoso.com or mobiledevice.contoso.com or whatever endpoint you actually want it connecting to. Finally, if you really have to, you can query for DNS. You can query DNS for serve records that point to autodiscover. This is the least favored approach, and I don't think I've ever seen a client actually implement it since probably 2007 or 2008. So, assuming that we reach one of these endpoints, the client may receive one of several responses. It can get back a 302 redirect. It can get back the actual manifest, which is what we would prefer. It can get an error from autodiscover that said, I got your request and for some reason I couldn't answer it. For example, you will sometimes see this in Exchange 2013 when connecting to a CAS for no good reason than I've been able to figure out. So your client has to have a certain amount of retry logic in it so that when it gets an error like that, it can try again, back off and try again after a period of time. You can get 401, 403s indicating that you have to re-authenticate. 404s generally mean that the autodiscover endpoint is not actually there, in which case you're going to try another well-known URL further down the list. And then you may actually get an HTTP error depending on your request type. I mentioned the 451 redirect that sadly has gone away. Now, I included this URL, and these slides will be available on ComNet if they're not already. I included this URL because it's a really good guide to using autodiscover if you are developing applications to use Exchange ActiveSync. Even if you're using autodiscover as a front end to find and talk to Exchange for EWS, this guide is really well written. It explains everything you need to know about the order of operations, what kind of data you'll get back, and so on. So this is an actual piece of code from the demo app that you're going to see in just a minute. And I want to take a second and talk about it because it is funny looking. Great, now I'm armed with a laser. Just what I've always wanted. How many of you have seen or programmed in Objective-C before? Okay, scattering of hands. How many C#? Okay, C++? Okay, good. So the first thing you have to know about Objective-C is that it's weird. Okay, it's weird because it came from California. It's also weird because it descends from Smalltalk. And so it has many of the same features that other programming languages do, but because Californians are weird, and I say that having just moved out of California after a lengthy stay there, there are some syntactical differences that you have to recognize in order to see what Objective-C code is actually doing. So this if statement, this is pretty straightforward, right? And if you're familiar with object-oriented languages, you're familiar with the concept of there being a self object that has some kind of properties on it. But these brackets often confuse people. So when you see brackets in an Objective-C program, what you're really seeing is a method call. Apple doesn't call it that. They call it sending a message to an object, but what you and I would call it is calling a method on an object. So here, I'm going to, the AutoD object, I'm going to call its connect to server method. And that's going to return a Boolean value. You know, it's implicit. You don't see an assignment here, but this whole thing in brackets is going to return a Boolean. If that's true, then I'm going to set the server URL member of self to the result of sending the server URL accessor to the object. Okay? Then once I've done that, I'm going to, on the oof property of the self object, call the getCurrentOofState method. So if you look at this code and just read it out as English pseudocode, if I'm able to connect to the server, then I'm going to set my copy of the server URL to be the copy of the server URL that I got from my AutoDiscover object. And then I'm going to tell my copy of the oof object to get the current oof state. Clearly, this is not exactly how you would write it in another language, but I hope the intent of what this code actually does is clear, so that when you start to see more complex code in about 30 seconds, you won't look at it and go, I don't even know what that is. This is a very small excerpt from the app I'm about to show you. Okay, so what you're looking at now is you're looking at a little app I wrote to let you see and change the out-of-office state on iOS devices. Now, Windows Phone can already do this. BlackBerry devices have been able to do this for years. But if you have an iPhone and you go to Madrid and you realize once you get to Madrid, oh, I forgot to set my out-of-office message, no one will know where I am. There's no way to do it on the device unless you want to load up OA in the web browser, which on a small phone screen is really painful. So we can fix that by using this app. So what I'm going to do is set a message. And I'll turn on automatic replies. And then I'll push those changes to the server. Now, if you look, for some reason, the device organizer came up. If you look down here in the console output, you'll see a bunch of stuff and junk. Okay, we're going to talk about what those things are in just a minute. Okay, you can see down here that I made a request. Hey, and it failed. That's interesting. All right, well, let's try it the other way then. Okay, so now I've set my automatic reply message here in OA. Interesting. Well, I guess I should have shown you the code first before the demo, because this is going to be a little anticlimactic. But for some reason, when I look at this response, we're posting get user OOF settings, and we're getting back a failure with a result of null. So in a minute, we'll set a breakpoint and see if we can chase down exactly why that's happening. But in the meantime, let's talk about why this code is structured the way it is and what it's supposed to do, even though it's not doing that right now. So I talked a few minutes ago about auto-discover. And if you look at the mechanism we use to do auto-discover in this app, there are two different ways that you can do it. You can do what's called POCs, or just plain old XML. That's where you build an XML block, push it to the server, and let the server interpret it. What Microsoft recommends that you do in Exchange 2010 and later is to use a SOAP-style interaction instead. So that's what we've done here. Okay, we build this block of XML that includes the email address that we want to do auto-discover for. And then we use a third-party library called ASI HTTP request. And I think I have a slide a little bit later talking about these libraries, but one of the key advantages to the iOS platform is that there are many, many, many third-party libraries to do interesting things. So whereas on Windows Phone or Windows, you would use system.net.socket to do this kind of stuff. On Mac OS and on iOS, you don't get that provided library, right? You can write raw sockets using CF Network, or if what you want to be able to do is to do HTTP level requests and not have to worry about the abstracted details of a socket, you can use something like ASI HTTP. So what this code does is it creates a new request for a particular URL, where that URL comes from the URL that we specified as part of the auto-discover process. We set some credentials. Then we actually post the result. Now, when the result comes back, it's going to be in the form of, and I think I have an example here. No, I didn't keep my auto-discover example. So when it comes back, it's going to be a block of XML data too. And what we're really looking for is this auto-discover element, which will have a response, which will have a user, which will have an auto-discover SMTP address node below it. So we're actually using the GData XML parser, which Google makes available as open source. Now, this is very much a good news, bad news situation. The bad news is I don't like Google. I don't like doing business with them. I hated living in Mountain View near them. But on the other hand, they make the best available open source parser for iOS. It's the best combination of flexibility, speed, memory use, and footprint. So I had to compromise my principles a little bit and use something that Google made, drawing some comfort from the fact that they don't profit from it because it's pure open source. That helped ease my conscience a little bit. So the XML parser lets us pick through this complex XML response and get only the nodes that we care about. So in this case, the only thing we care about is the user's email address. And then the auto-discover manifest itself can have 3 different Exchange providers. This may be a familiar term to you if you're used to working with Exchange. But it turns out that the only provider we care about is the Exchange Web Services provider, because we're not doing Outlook Anywhere. So we don't care about either of the Outlook Anywhere providers. So the thing that we're looking for right here is this one entity called ASURL. That's the entity in the auto-discover response that gives us the URL that we need to do Exchange Web Services stuff. So now that we've got that, remember this is just auto-discover's connect to server method. Now that we've got that, we can use it here when we want to get or set the OOF state. So here, to get the OOF state, we've got this block of XML again. So here's the address where we plug in the user's email address, and it turns out that this is inside a get user OOF settings request. So this is a set request, which looks very similar in that the request itself has an XML namespace associated with it, but it specifies a mailbox element which contains an address element. So if we were just saying get user OOF settings, we'd say get user OOF settings request with a namespace, a mailbox with a namespace, and then the address we want, and that would be it. For the set, we also have to specify what we want those settings to be, as you'll see in a minute. So we build the request, and we send it, again, using an HTTP post. So this time what I'm going to do is I'm going to set a breakpoint here because I want to see what response we get back. And then based on the response, if there's no error, we use gdata XML document to pick the response apart, because that's what's going to tell us what message the user has set for their OOF response. It tells us whether they have the external audience flag enabled or disabled. It tells us what the message text should be, and so on. All the things that you see when you set or change OOF properties using OA or using Outlook are all exposed here, right? So this is a good example of the kinds of things you can do with EWS. You have a block of state data that Exchange has, indicating whether or not this person is in the office, when are they in the office, when does their message stop working. All those things are available to us from right here. So after we get that block of data back, then we just parse each of these individual elements by using nodes for XPath on the document. So in this case, we want the S body, M get user OOF settings response, T allow external OOF. In this case, S, M, and T are namespaces that we've abbreviated using the namespace expander that's built into Google's library. So for each of the data elements that can come back, we've got whether or not allow external OOF is turned on, the external reply, the internal reply, the duration of the message, whether it should be sent to the external audience or only to people within the organization, and then finally whether or not they're in or out. So we capture all these things as properties, and then in another piece of code, we use those properties to light up the user interface elements and fill in their values to flip switches and show dates and times and so forth. So what I'm actually going to do now, I want to stop this and rerun it and see if we can catch the cause of the error. Because I know you've probably all heard this a million times before, but if I had a stack of Bibles, I would put my hand on it and swear these demos worked yesterday in the speaker lounge and they worked last night in the hotel room. Okay, interesting. So we got a status code of 0, which is normally good, but the request itself said that it failed. Okay, unable to create request, bad URL. So that is interesting in itself. Okay, tell you what I'll do. I want to press on with the presentation because I have a few other things I need to show you. I think I know what the problem is, so we'll see if I can debug it when I'm done talking about the stuff that I'm supposed to be talking about. So we've already run through some of this code looking at it in Xcode, but this is a sort of abbreviated version that we can talk about here. One of the drawbacks to anything involving code, of course, is that it's really hard to see unless you make the letters really big, and then when you do, you only get a little tiny bit of code on each screen. So if you look at what's going on here, we're going to make a new request using the server URL that's known to the application delegate. And if I had to guess, I would say this is where the problem that we just saw in the demo is coming from. That in some way, the server URL is bad because it gets set. The application delegate object is a top-level container object that has application-level properties. So my guess would be that that's broken somehow, and that's what's making our requests fail. So we get the current user from the app delegate, and then we use that username and password to set credentials on the request. We specify that this is a text XML request. Then we take the request itself and add it as post data to the request object, and then we start the request object. Now, the only reason I did this synchronously is because I didn't also want to have this be a discussion on how iOS threading works. Okay, obviously in a real application, you would want to spin off a thread anytime you're going to do a long-lived server operation, such as trying to do an auto-discover. So the server gives us back an XML document that we now have to parse. And I already ran through this. One thing I should probably back up and ask if y'all are familiar in general with XPath. Okay, if you are, great. If not, I want to take, say, 30 seconds and talk about it very briefly. Any of the specs that you're familiar with or may be familiar with that include the word path in them generally indicate that it's meant for some kind of parsing, right? So we have OPath, which is a replacement query syntax for LDAP language queries, right? If you remember or have ever had to work with exchange filtering in Exchange 2000 or 2003, or if you're used to building LDAP queries to query things from Active Directory, then you know that OPath is a considerable improvement. All XPath is it's a way for us to say, okay, in this really complicated XML document that can be nested many levels deep, I want to pick out one particular item. I want the email address item of the user object that's buried within this entire tree. Well, XPath gives you a way to specify something that looks very much like a folder path in Windows, where you say, go to this element, and out of this element, pick this child, and out of that child, pick this child, and out of the 5 possible children that it can have, enumerate through each of them until you find the one element that I'm actually looking for. Okay, well now we know that at least the laser pointer on this works, even if the rest of it doesn't. So how do we set the OOF state? I showed you a little part of what that code looks like, but really what we're essentially doing is a big printf. We have a block of XML that we know the server will accept, and we just need to plug in the values for things that we care about, making sure that we put them in a format that Exchange will accept. As an example, When we push the OOF state up to the server, if we want the OOF to take place at a certain during a certain defined duration, then we have to make sure that we specify the time zone both for the starting time and the stopping time. Now, the web services book doesn't tell you this, but those time zones have to be the same. So Exchange will not accept a request when you say that you want to start your out of office at 7 a.m. Central European time, and you want to end it at 4 p.m. 2 days later, Central Daylight Savings Time in the U.S. Why? I don't know. That's just a restriction that they put in place. There are others. As you'll find, the Exchange business logic enforces the process of making sure that whatever you put into a request meets its requirements. And it has to do this because in cases when it doesn't, sometimes we get bad results. A long time ago, maybe Outlook XP, there was an Outlook bug that would sometimes create calendar appointments in Exchange where the ending time was before the starting time. That would make the Exchange information store crash. So there was a lot of yelling and going back and forth between Building 34 and the Office team. They fixed it. Some of you may remember earlier this year there was a situation where an iOS device could actually hijack a meeting and generate thousands of meeting notifications under a very certain set of conditions. Well, it turns out this is an exact case where the business logic on the Exchange server didn't catch something that it should have, right? If you're a meeting attendee, should you be able to change the meeting organizer? No, of course not, right? I don't get to walk into a room here at the conference center and say, oh, sorry, I know Mark Rasinovich was scheduled to talk today, but instead I'm going to talk. How about that, right? So there's no Exchange, or there was no Exchange business logic to prevent a meeting hijack from taking place. Okay, but in general, you will find that when you create these items and send them, if you violate any of the constraints that Exchange has on how things are supposed to work, that it will cause a failure. Now, I want to switch gears for a minute and talk about calendar management, because this is a very common request for computer-enabled business processes. People want to be able to write programs to do things to calendars. Mobile devices have already got calendar apps on them, which are great for managing your personal calendar. But suppose you wanted to look across multiple calendars from a mobile device. Let me give you an example. You've all heard of Boeing. Boeing actually has a team of people whose job it is to investigate any kind of major systems failure or crash or malfunction of a Boeing aircraft. But they also have another team, and this is really cool, that goes, if an aircraft is badly enough damaged that the airline that owns it can't easily fix it, then Boeing will send out sort of this SWAT team. They did this 3 years ago at Charles de Gaulle. A luggage truck hit an aircraft in its tail cone, and it broke the pressurized bulkhead at the back of the airplane. You can think of it like a cap. It's a hemisphere that's bolted onto the end of the pressure vessel of the fuselage. And because it was damaged, Air France didn't happen to have another one. You don't keep these things lying around because they cost millions of dollars, and you can't fix it with duct tape. So Air France got on the phone to call Boeing and said, hey, Boeing, we need you to send your expert airplane fixers out here and fix this thing. And Boeing said, okay. Think of the utility if you could have a handheld device that at the push of a button would let you see who is available on call to do that. Because for a situation like that, you need a structures guy, you need metallurgists, you need airframe and power plant mechanics who are certified in whatever country you're going to work in. You need an IA, an inspector authorizing. So in other words, there's a set of people that you need, and it doesn't matter if Frank or Steve or Paul or Mary is the A&P mechanic. You just have to have one of the four. Well, now, given all the data we have in Exchange, it's really simple to write an application that says, okay, great, pick me a team. Find all the people who are in the office, not out of the office, not on vacation, not on maternity leave. they have availability, and then bang, with one button you can schedule a group link call, you can send an email to them, you can put stuff directly on their calendar. There's all kinds of nifty stuff that you can do that you can't do with the basic built-in applications. So I'm a little gun shy after that first demo, but because I am optimistic by nature, let's try again with a different tool. Okay, you'll notice here I've got a big old block of XML, and you're going to see what that's for in just a moment. There we go. Oh, you know what? It might help. That was totally my own fault. I had told it to get events for the week of TechEd, North America only. And since there are no longer any events on my demo calendar for that week, I didn't get anything back. Oh, come on, now you're just playing with me. Okay, so there are in fact events on the calendar. And let's see, start date is the 3rd, end date is the 30th. All right, so just for fun, let's do this again, because now I'm curious about where these calendar items went to, or if there's something else going on that's hidden, like that bad URL problem we just saw. Okay, well now, at a minimum, we've got an item that should show up. Well, I apologize. This demo is even worse than the first one. But we can at least talk about what was supposed to happen, and I can show you the code that backs it. In this case, what we want to do is actually use an EWS call to do something. When we first got started, we were just making a simple EWS call that works on a single purpose-built item. So when you call get OOF status or set OOF status, there's only one OOF status per mailbox. On the other hand, when we call find item, we could be finding any kind of item anywhere in the mailbox. Calendar items, contacts, mail messages, folders. So specifying what Microsoft calls the shape of the thing we want to find is really important. So in this case, what we wanted is we wanted to define a shape for events during the week that we were interested in. So in this case, the way that we do that is by using find item. And you can see up at the top, the second line, when we say item shape, this is where we specify the definition of the shape that we want. Now, this is not arbitrary. Okay, we have to use a base shape of ID only to indicate that we're looking for things and want the ID or identifier of the thing that we find returned. And then we said that we want 3 calendar properties: the start date, the end date, and the item subject. Now, we could specify different fields in there as long as they are fields that are within the schema for that particular item shape. This is the hardest part of working with find item and create item, because if you get the shape wrong, you can think of it like a template for a tattoo. If you go to the tattoo parlor and you pick out a design, that's the design you're going to get. And if that design doesn't have space for something that you want, maybe you wanted a heart and you wanted to say the heart to say mom. If the template doesn't have a place for mom on that template, then you're not going to get that on your arm. So picking out the right item shape and then making sure that you fill out the properties that you're either asking for or setting is really critical. Because as it turns out, if you leave out a mandatory property, you'll get back a constraint error from EWS. Okay, and that can happen in either direction, either with find item or create item. In this case, what find item will return is a structure that can have 0 or more results. It's perfectly okay for a find not to find anything, in which case you get back a 0. It also can return as many results as you've specified that you're willing to accept. So when we look at the find item here, in this initial block, what we've specified is that we will accept up to 500 items in max entries returned. So in this case, this is the find item response, the find item request that we made. And then to look at the items that come back, we'll flip back over to Xcode. And see that from our request, we should be getting back an XML document. In that XML document, it'll contain an item called find item response, and this is what's actually got the contents. So if we use XPath to say in the body, in the find item response, in the response messages, in the find item response messages, then we should have a collection called items, and there will be 1 or more calendar items. Well, this is cool because what nodes for XPath does in this case is give us back an array of items. And since we have an array, we can do things like make sure that we got a result and that the result has more than 0 items in it. Then we just iterate over each item and add it to our table view. Okay, so that's what fills in that view on the left-hand side when we actually get results back. To add a calendar item, we use create item, and here the shape is even more important. Think of it, instead of a tattoo, being like a cookie cutter. So we'll create a basic shape that says I want to create an item of some kind, and then we specify the properties that the item shape should actually have. So all of this blob right here is the calendar item shape itself. So we'll make it a little bit easier to read. So you can see here, part of the shape is I have to specify where I want the item to be saved. In this case, it's in the calendar. I'm only creating one item, but I could put more than one. It's a calendar item. And that means it's going to have a set of parameters, some of which are optional, some of which are mandatory. For example, it is not mandatory that I include a location for this calendar item, but it is mandatory that I include a start date and time and an end date and time. The shape says so. So how do you know which of these properties are required in a shape and which ones are optional? Trial and error, usually. You can actually look at the specs on MSDN, but in my experience, they're not complete because there have been new properties added to some of these item shapes over time. But if you look at what's happening here, everything that you see here is familiar from the context of creating meetings or appointments in Outlook. The one part that may seem a little bit odd is that here you have two attendees. If you create a meeting request, if you create a meeting, you need to include the address or addresses of the attendees, but you also need to use the address, include the address of the mailbox that's generating the meeting. So in this case, this is running against the demo@roboshow.net account. So notice there's no place to specify the meeting organizer. Microsoft assumes that whoever creates the meeting is the meeting organizer. That's different, say, from Lotus Notes or from GroupWise. They have this concept of the person who sends out the meeting invitation and the person who's running the meeting being possibly two different entities. But here, if you leave out that demo@roboshow.net as an attendee, then the recipient will get an invitation, but it won't show up on the creator's calendar, which is generally not what you want. So I want to briefly talk about some Exchange 2013 specific things that you can do with Exchange Web Services in your own applications on whatever platform. First is a unified contact store. The idea here is that right now, Lync has its own SQL database where it keeps your contact list. That's wasteful, and it's inefficient because you've already got a contacts list. It's called your contacts folder. So now in Lync 2013, with Exchange 2013, Lync has the ability to use Exchange as the contact store. So when this is enabled, and you have the Lync 2013 client running, then the Lync client will take your existing contact list out of the SQL version of the store and store it as a new folder called Lync Contacts inside your contacts folder. How many of you are running Outlook 2010 or 2013 and have seen the suggested contacts folder? Same exact idea. Okay? They're contacts, but you don't necessarily manage these contacts yourself directly in the way that you do in the contacts folder. You can delete them, but if you delete them, they disappear from your Lync contact list. If you put a new contact into your Lync list, then it should show up in the Lync contacts folder. That two-way sync does not work right now, but I expect that to be fixed shortly. High-resolution photos. Okay, we've had thumbnail photos for users for a while. They get stored in AD and can be displayed in Outlook or in Lync. But the problem is that in some cases, Lync needs a bigger picture. When you get an incoming call from a person and Lync pops up the call notification, if it has to take that little 64 by 64 thumbnail photo, postage stamp photo, and blow it up, it looks really jaggedy and terrible. So now, in addition to all the other stuff it stores, Exchange lets you post a higher resolution user photo that it will then downsample and make available automatically. So you put in 648 by 648, which Link 2013 will use natively. Exchange will downsample it to 8 or 9 resolutions, including downsampling it to 64 by 64 and putting it into the thumbnail photo attribute in AD so that Outlook 2010, Outlook 2011, and Link, at least Link 2010, and I think Office Communicator 2007 R2 can all see and access that picture. You can get it directly in your code in one of two ways. One is that you can get it by using this URL, or you can use EWS. There's a new item called, or new command called get user photo, where you specify the user you want and the resolution you want, and you get back either a PNG or JPEG of the data. E-discovery and retention. I threw this in just because it's cool. I don't think anybody's likely to write a mobile app that lets you do discovery searches or put somebody on legal hold or take them off legal hold. But we have APIs to do that now. And the picture that I hope you're getting is that when Exchange ships new features in a new release, they're getting much better about including EWS support for those features right away, instead of making us wait 1 or 2 service packs or cumulative updates later. Okay, a few resources. This MSDN article about new features in EWS in Exchange 2013 is very good. You're welcome to follow me on Twitter or follow my blog. I often talk about EWS and iOS-related development stuff, along with aviation and restaurant reviews. Really, really, really strongly encourage Exchange people to make plans to attend MEC. If you were able to go to MEC in 2012, you know what a fantastic conference it was. If you didn't get to go, put it this way, if I had to pick between going to TechEd and going to MEC, I would take MEC, hands down. Next year, MEC is going to be in April in Austin, Texas, and TechEd is going to be in May in Houston, Texas, which is about 110 miles away. So, I'm just saying, if you have to choose one of those two, I would hope to see you all at MEC. And if I get to see some of you at TechEd too, as a bonus, that's great, but that ends my commercial about that. Okay, you've seen this slide before. Please evaluate this session, even though I suspect I know what many of you are going to say about my demos. That's fair. But the evaluation data is really important to the TechNet people because it helps them plan how they're going to allocate sessions. They know how many people are here, so next year if I do this session, they'll probably give me a smaller room, which would be okay. But seriously, the evaluations are important. And you can win fabulous prizes. Now, I've got a few minutes for questions before they come and throw me out in favor of the next speaker, if anybody has any. Yes, sir?
Why does not an application in Windows exist using the ActiveSync protocol?
That's a really good question. Why aren't there any applications in Windows that use ActiveSync? And it turns out there are. For example, Windows 8 Mail. The Mail application that comes with Windows 8, yes. When you configure it to use an Exchange account.
ActiveSync exists for a long time.
Yeah.
It does not exist, or it's
Microsoft is even starting to use ActiveSync. They're using it in Windows 8 Mail. They're using elements of ActiveSync in Outlook. And so what I think is going to happen is that over time, ActiveSync is going to become the protocol that Microsoft uses for all of their mail applications across all their devices. Until now, there are still things that you can do in MAPI that you cannot do in EWS. But they're trying to reach parity between those two. And I think that as EWS gets better and gives you more functionality, that you're going to see a movement toward using that as a primary mechanism, because it means that there's no RPC anymore. Everything that you do goes over HTTP or HTTPS. It has very lightweight synchronization, which means it's great for a tablet or a mobile device or a low-power PC, or a home PC where you don't want the PC to be powered up doing stuff all the time. You want it to wake up every so often, pick up any new mail, notice any changes, and then go back to sleep until somebody's getting ready to use it. So I think we are going to see ActiveSync used more often on Windows now.
Devices, it's okay, but on the Windows platform, I didn't find something.
There isn't any, other than Microsoft's own application right now. But I think that's just temporary. I think you're going to see that grow in the future. Yes?
Can you use EWS to access another person's calendar that has delegated access?
Yes, that's an excellent question. Can you use EWS to access someone else's calendar to which you have delegate permissions? Yes. Now, there are a couple of ways to do that. If you have delegate permissions, you can log in as your account and then read their calendar, and Exchange handles that delegation. You also can use something called EWS impersonation, where you use your account and you impersonate them. It's like the difference in Exchange between send as and send on behalf of. So depending on what you want to do, if you want to read their calendar and you've got delegate access, you can do that logging in as you. If you want to modify their calendar, then you use impersonation to log in as you with their privileges, and then you can modify their calendar. Oh, way in the back, sorry. How do you handle time zones? That's a good question too. So every time you do something in EWS that involves creating an item, you have to specify the time zone. Well, let me take that back. Anytime you do something involving an item that is associated with times, so if you're creating a folder, for example, who cares? But if you're creating a calendar item, then you have to specify the time zones that are applicable to it. The server will check validity to an extent. For example, if I say that an event starts at 7 a.m. Central European time and it ends at 7 a.m. GMT, since we're an hour ahead, then Exchange will say that that's invalid because the ending time is before the starting time. But in general, it doesn't do anything to make sure that your time zones correspond to what the user has set. For example, when I log into OA, my home OA is set to US Central Time. If I run a program that creates a calendar item on GMT, then it's going to go into my calendar as GMT. And OA will render it according to what OA thinks my local time zone setting is. I'm not sure how well that answered your question, but time zone handling is on you as a programmer. EWS doesn't do anything other than verify that you've specified a legal time zone and that the time zone you've specified doesn't cause a time machine situation where an event ends before it starts or something of that nature. Yes?
How expensive is auto-discover from a mobile perspective in terms of time? How long do you use that to do your work with in terms of the URL to get back?
Oh, that's a good question. How long does auto-discover take? What I found is that on average, using Office 365, it takes between 8 and maybe 10 or 15 seconds for an auto-discover request to complete. Now, part of that is because when I run those requests, I'm almost always doing it on a simulator, running on a laptop on a low bandwidth conference style connection. But you can get a good sense for how long it takes if you create a new account on your mobile device and plug in the credentials, or matter of fact, if you do it in desktop Outlook, because there are multiple endpoints to try. And so depending on how the end server is configured, if you try the first endpoint and don't get a response, and you have to wait for that to time out before you can try the second one. I would say if you routinely see the request taking longer than 30 seconds, something is probably wrong.
How long do you keep, if you have a number of actions you need to do, so how long do you keep your auto-discover session? It's expensive to get it in the first place.
Right.
How long do you keep it for?
Oh, okay, I'm sorry, I misunderstood the question. So it'll be valid for a while, okay? Because when you initially do the auto-discover, you know at that time that it's valid, but at any time after that, it could be 5 seconds after, it could be 5 months after, the user's mailbox may move, right? And that may be an explicit mailbox move that's done by the administrator, or there may be either a failover or a switchover that means that they're now on a separate mailbox server. So what Outlook does is every 90 minutes it reruns auto-discover. And if at any time it loses connectivity to the client access server or mailbox server that it's talking to, then it re-auto-discovers. What I would say for a mobile device app is that when your application wakes up, and on iOS, and this is probably true on other platforms, but on iOS you get an event that says you are waking up for the first time after a long time, and there's another event that says you're waking up after just having been suspended a short while ago. So I would say when you get the you're waking up after a long nap, re-auto-discover. For short suspensions, use your judgment. If you find that you're frequently not connecting to the endpoint you thought you were getting, you might want to auto-discover every time. But if you do that, that would be a case where you would probably want to do it asynchronously so the user is not having to sit there and watch the spinner while you finish the auto-discover process. Do I have time for one more, Harry, or are you throwing me out?
I'm going to ask you to take any other questions outside.
Okay.
Sorry.
Great. If you do have other questions, please meet me out in the hall and mock my demos.